Assign cookies looks like a complex matching problem that needs a recursive search, but there is a simple greedy trick that makes this a breeze. The goal is to maximize the number of content children. We are given two arrays, one representing the greed factor of each child, essentially the minimum cookie size they need to be happy, and another representing the sizes of cookies we have available. A child is content if the cookie size is greater than or equal to their greed factor. For example, if we have children with greed factors of 1, 2, and 3, but only 2 cookies of size 1, we can only satisfy one child because the second cookie is too small for any of the remaining children. A naive approach would be to use backtracking to try every possible combination of cookies and children to find the absolute maximum. We would track which cookies and children are used, recursively exploring all permutations. However, this is incredibly inefficient, resulting in exponential time complexity of m factorial times n. With even a small number of cookies, the recursion stack and the number of permutations would cause the program to time out or crash. The key insight is that to maximize content children, we should satisfy the least greedy children first using the smallest possible cookies that meet their needs. First, we sort both the greed factors and the cookie sizes. Then, we initialize 2 pointers at the start of both arrays. We loop through the arrays, checking if the current cookie is large enough for the current child. If it is, we move to the next child. Regardless of whether the child was satisfied, we move to the next cookie because the current one was either used or too small. The final count of satisfied children is simply the position of our child pointer. Let's trace this with greed factors 1, 2, 3 and cookies 1, 1. After sorting, both arrays stay the same. We start with both pointers at index 0. The first cookie of size 1 meets the first child's greed of 1, so we increment both pointers. Now, the second cookie of size 1 is compared against the second child's greed of 2. Since 1 is less than 2, the child isn't satisfied. We move the cookie pointer to the end. The loop terminates, and our child pointer is at index 1, meaning only one child is content. You'll recognize this pattern when you need to maximize a count by matching resources to requirements, where sorting the inputs allows a local optimal choice to lead to the global optimum. The time complexity is dominated by sorting, making it O, n log n plus m log m. The space complexity is big O of 1, constant time, or big O of log n, logarithmic time depending on the sorting implementation used. Try the lemonade change problem next. It uses the exact same greedy logic. Subscribe for more DSA deep dives.